In the dead of winter, the North Atlantic doesn't care how big your ship is. Waves rise 5 stories high, winds scream past 70 knots, and the air is so cold that seawater freezes the instant it touches steel. From 1940 to 1943, this grey churning chaos became the single most important battlefield of the Second World War. Not for territory, but for the convoys that were Britain's lifeline. What seems almost impossible is that tiny British destroyers, some weighing less than 2,000 tons, relentlessly hunted German U-boats through storms so violent that German destroyers, many of them twice the size, were forced to abandon their patrols and run for the safety of port. The smaller ships won the war against the weather, and that crucial edge helped turn the tide of the entire Atlantic campaign. Take the night of February 17, 1943. A British V-class destroyer, HMS Vanquisher, is holding its position northeast of Iceland in a force 9 gale. Her crew is tracking a U-boat, fighting both the enemy and the sea. Meanwhile, their German counterparts aboard the much larger Z-class destroyers. Ships supposedly built for superior seaworthiness were already retreating towards the calm waters of Norwegian fjords. This wasn't an isolated incident. British reports from that winter tell the same story over and over again. British escorts stayed on station. German surface raiders withdrew, but this wasn't just a story of courage defeating fear. Sailors in both navies were incredibly tough. This was a story of engineering defeating engineering. It was design, not just bravery, that decided who could fight when the ocean itself became a weapon. On paper, German destroyers looked far more formidable. The Type 1934 A-class rode higher in the water, carried heavier guns, and had the range to roam far from home. They were crafted by skilled engineers who understood hydrodynamics, but they were built for the wrong ocean. The war diaries of the German Navy, the Kriegsmarine, are filled with the same frustration. Operations ceased due to weather. At the same time, British destroyers, many of them older, pre-war designs considered outdated in peacetime, just kept hunting. They maintained sonar contact in seas that should have made sonar useless and pressed home attacks in conditions that German naval doctrine considered impossible for surface ships. This advantage wasn't a fluke. It was the product of generations of British experience in the brutal waters of the Atlantic. Centuries of shipbuilding, tested through gales off the coast of Scotland and the unforgiving western approaches of World War I, had shaped destroyer hulls that learned to work with the sea, not fight against it. German naval design, on the other hand, had evolved for the Baltic and the North Sea environments with shorter, steeper waves and more sheltered conditions. The Kriegsmarine prepared for quick, decisive battles close to home, not for the endless, punishing swell of the open Atlantic. By 1943, this design difference had become a massive strategic problem for Germany. U-boat commanders began to dread winter patrols because they knew their surface support would vanish the moment a storm rolled in. The infamous Wolfpack tactics that terrorized convoys in 1941 relied on German destroyers for weather scouting and coordination. But when those destroyers were constantly being driven back to port, the entire system started to collapse. British captains, by contrast, knew their ships would answer the helm even in seas that broke larger vessels. They fought through storms that grounded their enemies. So, how exactly did these lighter, older destroyers manage to outperform newer, heavier ships? The answer lies in a handful of deliberate design choices, some dating back to 1918, that traded comfort for something far more important: the ability to fight when the weather turned murderous. After the Treaty of Versailles limited Germany's navy, their destroyer construction in the 1930s focused on a specific goal. The Type 1934 class was designed as a fleet destroyer for the North Sea and the Baltic. German designers prioritized speed and firepower. The ship could hit 38 knots and carried 5 powerful 12.7 centimeters. Guns. It looked incredible on paper. To achieve this, they designed the ships to ride high in the water with tall freeboards, which helped keep the decks drier in the short, choppy waves of the Baltic. It worked perfectly there. But in the Atlantic, that same design turned the ships into towering levers that the wind could grab and twist with every storm. The Royal Navy's approach was born from painful experience. Early 20th century destroyers had proven too lightly built, sometimes even breaking their backs in heavy weather. But by World War I, designs like the V and W classes had taught them a hard lesson: to survive the Atlantic. A destroyer's hull had to work asterisk with asterisk the swell, not just ride over it. By the 1930s, this lesson was doctrine. The official requirements for the 1927 Atlas destroyers demanded full combat effectiveness, not just survival in force 8 conditions. That meant winds up to 40 knots and waves 25 feet high. That single requirement shaped every destroyer class that followed. Each new design was tested in the North Atlantic's worst weather until it could not just endure a storm, but actively fight through it. The secret was in the shape of the bow. If you stand beside a preserved British destroyer like HMS Hesperus today, you'll notice something unique. The bow doesn't just cut vertically into the sit, flares outward, while the part of the hull just below the waterline, the forefoot, extends deep into the water. This combination was the Royal Navy's brilliant answer to the Atlantic's most dangerous question: how do you stop a destroyer from being thrown backward by a 40-foot wave? A flared bow doesn't meet a wave head-on, it deflects it. As a wave strikes, the water is pushed outward, splitting it instead of letting it crash over the deck. At the same time, the deep forefoot acts like a knife, cutting into the base of the wave before the rest of the ship even gets there. Together, these features allowed the ship to slice a massive swell into manageable pieces rather than taking its full, brutal impact all at once. The result was astonishing. British destroyers could maintain speeds of 18 to 20 knots through seas that forced other, larger ships to a crawl. German designs lacked this sophisticated shape. Their bows were steeper and their forefoots were shallower, perfect for the Baltic. But a disaster in the long, rolling waves of the Atlantic. Logs from the German destroyer Z-31 in 1943 describe its bow lifting completely out of the water, its propellers spinning uselessly in the air, followed by a violent, bone-jarring slam as it crashed back down. The ship survived, but fighting was out of the question. Meanwhile, in similar Force 9 seas, the British destroyer HMS Cossack was maintaining full control at 22 knots. Her captain reported the ship was heavy weather working, but remains under full control and combat capable. That phrase, combat capable, was everything. Any ship can try to survive a storm. But only the British destroyers were designed to fight through one. And it wasn't just the bow. Stability wins wars. British escort destroyers sat low in the water with what seemed like a dangerously small amount of hull visible above the waves. Observers initially thought these ships would be swamped by the first big wave, but when HMS Brecon sailed through a force 8 gale off Iceland in 1941, the crew saw the truth. The lower design meant incredible stability. A lower freeboard lowers a ship's center of gravity. Think about it. Every ton of weight positioned high above the waterline acts like a lever, increasing how much a ship rolls in the wind. The tall, top-heavy German destroyers could lean over 15 degrees just from a strong crosswind, and that was before a wave even hit them. Under the exact same conditions, the lower-slung British destroyers leaned only 6 to 8 degrees. That difference meant everything. It meant British crews could still stand aim and operate their guns and depth charges, while German sailors were just desperately clinging to railings to avoid being washed overboard. In the end, both navies produced incredibly brave men, but only one of them designed ships that truly understood and respected the world's most hostile ocean. The North Atlantic didn't reward raw strength or impressive statistics, it rewarded understanding. And in that brutal, unforgiving classroom, the British destroyers had already done their homework. Thanks for watching. If you found this story of naval engineering fascinating, be sure to hit that like button and subscribe for more deep dives into history. We'll see you in the next video.